So today I'll be calculating the amount of energy in Meltryllis Kick. Before I get into that, let's explain what energy is. Energy is a concept that is meant to explain how things do work, or as defined by Google, energy in physics, the capacity for doing work. It may exist in potential, kinetic, thermal, electrical, chemical, nuclear, or other various forms. After it has been transferred, energy is always designated according to its nature. In every situation, there are tons of different types of energy present, but for the simplicity of this project, I will be only addressing 3 of them. The first energy I'll be going over is chemical energy. Chemical energy, or as defined by Google, energy stored in the bonds of chemical compounds. Chemical energy may be released during a chemical reaction, often in the form of heat. Next is kinetic energy. Kinetic energy is the energy an object has due to its motion. As long as an object is moving at the same velocity, it will maintain the same kinetic energy. The kinetic energy of an object is calculated from the velocity and the mass of the object. Finally, we have gravitational potential energy. Gravitational potential energy is a potential energy stored in an object based on its distance from the Earth. Here are the energy values prior to the jump, so let's go over each of these values and explain why they are the way they are. First, chemical energy. According to hypertextbook.com, human females have around 7.5 megajoules of energy per day, but for the sake of simplicity, we'll round it up to 8. That is why in this graph, there are 8 megajoules of chemical energy and 8 megajoules of total energy, because you have all chemical energy and no other type of energy. Now we go to the peak of the kick. In order to figure out the gravitational potential energy in this situation, we'll need her height, how high off the ground she is, and gravity. Gravity is 9.8 meters per second, but for this class we use 10 meters per second. According to the Type Moon wiki, and on her character profile, it says that she is 190 centimeters, or 6'2". For this equation specifically, we'll need the number in meters, and 190 centimeters is 1.9 meters. Now we need her height off the ground, which we can use the formula distance equals half of gravity times time to the second power, which is the formula for a free fall, which is pretty much what she's doing here. I did an average timing of her speed here and came out with around 0.53 seconds of airtime until she reaches her target. Plug in the numbers in, we get d is equal to 1/2 of 10 times 0.51 to the second power, and we get 1.3 meters away. Now we have all the numbers to calculate the gravitational potential energy, which is the mass times the gravity times the height. Height meaning her height and the height she is jumping from. From that, we get 53 kilograms by 10 meters per second by 1.3 meters plus 1.9 meters, which is her height. This totals up to 1,696 joules. This is equivalent to 4 times the force needed to break a bone. From this, we also have a leftover 7,998,304 joules of chemical energy. This is a mere 0.00002% of her daily energy. I wasn't sure if I needed to calculate it, but I did it anyways, so I calculated the amount of kinetic energy she used to jump to that height. Using the Lewis formula, I was able to get an average jump power. Average power in watts equaling root 4.9 times the body mass by root jump score in meters by gravity. Since watts are equal to joules a second, we have 183 joules a second. And since the jump is 0.53 seconds, we can cut that in half and get 91 joules of kinetic energy in the jump itself. In the kick itself, we have the kinetic energy, which is equal to half of her weight by the velocity to the second power. We get her velocity from the fact that velocity is equivalent to distance over time. Taking her 0.53 second air time and the 1.3 meter distance, we get around 2.55 meters a second as our velocity. Plug it in, and we get 172.31 joules. Add that to our total GPE, and we get a total of 1,696 plus 172.31, and we get approximately around 1,868 joules of energy in her kick. This is approximately 1,377.77 pounds of force, which is not a lot, but this is Rankine strength. Looking at the graph, we can see that all of the gravitational potential energy has been converted to kinetic energy as she goes down, and the chemical energy is at 7,998.41 joules of energy, because she did not use all her daily chemical energy in this single action. In conclusion, the kick can only break a few bones, and yup, that's because it's Rankine strength. Thanks for watching my TED Talk. I'm done making this video because it's horrible. Woohoo.